So as we press on, the next question we're asked is to determine whether the triangle is right angled. So going back from our previous example, or the first half of the example rather, we've learned that the side AB has length of square root of 10, side AC has length of square root of 10, and the longer side, which is side BC, has length of square root of 20. And we can use Pythagoras' theorem to show that a triangle is right angled. By that I mean, we know that for a right angled triangle, a squared plus b squared equals c squared. We can determine the lengths. We're going to flip that around and say, well, hang on. If the lengths obey this equation, the only way that they can obey that equation is if the triangle is a right angled triangle. So we're going to flip it around and use that as a proof. So what we can say here from this equation, length of AB all squared plus the length of AC all squared. And I'm doing this because I know that for a right angled triangle, it's the two shorter sides, sides A and B. We know that square root of 10 is less than the square root of 20. Equals 10 plus 10. I could rewrite that as equals 10 plus 10, which is equal to 20, which is equal to the square root of 20 all squared, which is equal to the length of BC squared. So as you can see, the way I've stepped through this, I've shown that the square root of both the sum of the squares of both shorter sides, equals the square of the length of the hypotenuse. So it obeys the Pythagoras' equation, therefore the triangle must be right angled. I can say over here, the triangle is right angled because its lengths obey Pythagorean theorem. Voila.